Are you struggling with quadratic equations? Is finding the solution confusing and frustrating for you? Well, you are not alone. But what if I told you that solving quadratic equations can be easy and fun to learn?
That would be cool.
In this session, we will explore the world of solutions of quadratic equations and also understand how to find the solution by factorizing. So quickly grab a pen and paper and let's get started. The first step is to understand the term roots of an equation. In the first session, we discussed how an equation is formed from a polynomial. So the concepts you know about polynomials are applicable in equations also. So do you remember zeros of a polynomial? Well, if we have a polynomial p of x, then a constant a is called a zero of p of x if p of a is equal to 0. In other words, when we replace the variable x by a number a, the value of the polynomial becomes 0. Now from p of x, I get the polynomial equation p of x equal to 0. So it means that when I replace x by a in this equation, LHS becomes equal to RHS. So the number a is called a solution of the equation and root is another name given to it. So if we have a quadratic equation ax square plus bx plus c equal to 0, then the value of x which satisfies this equation, or in other words which makes LHS equal to RHS, is called a root of this equation. The number of roots depends on the degree of the polynomial equation, and so a quadratic equation can have at most 2 roots. They may be real or non-real. We will discuss about the nature of roots in another session. Presently, we are only dealing with equations which have real roots. I mean only real numbers as solutions. Now that you know what is a root, let us first discuss how to check whether a given value of x is a solution or root of an equation or not. A solution is that which makes LHS equal to RHS, so we will simply put the value of the variable in the given equation and simplify both sides. Let's consider this example. Here the value of x is root 3. So putting the value, we get root 3 square minus 3 into root 3 into root 3 plus 6 is equal to 0. Or 3 minus 9 plus 6 equal to 0. Or minus 6 plus 6 equal to 0. As you can observe, the LHS and RHS are both 0. It means x equal to root 3 is a solution of this equation. Let's try this one now. Here x is given a upon b. So I'm replacing its value everywhere. And I have a square into a square upon b square minus 3ab into a upon b plus 2b square equal to 0. As there are denominators, we may cancel wherever possible. So finally I get a raised to power 4 upon b raised to power 2 minus 3a square plus 2b square equal to 0. The left hand side is an algebraic expression and it cannot be solved further. So it clearly means that left hand side and right hand side are not equal and hence this is not a solution. Understood? We can also have a problem where we are given the root of an equation but some coefficient of the equation is missing. Like this one, we are given that x equal to 1 upon 3 is a solution of this equation and we have to find k. As this is a solution, when we replace x by 1 upon 3, LHS is equal to RHS. So we get 3 into 1 upon 3 raised to power 2 plus 2 into 1 upon 3 minus k is equal to 0. Can you solve this to find k? You have to use the method of simple linear equations. So 3 into 1 upon 9 plus 2 upon 3 minus k equal to 0. Or 1 upon 3 plus 2 upon 3 is equal to k. Since they are fractions, we will take LCM and we finally get k is equal to 3 upon 3, that is 1. In the next one, x is equal to a is a solution of this equation. Let's start. A square minus a into a plus b plus k is equal to 0. Open the brackets and we have a square and minus a square which can be cancelled. And finally, taking the terms to the other side, we get k is equal to ab. Is the method clear to you? This was a simple one. but we can also have a situation where we have to find out two coefficients, and in this case two roots will be given to you. Remember this fact that whenever we are to find two things, we should have two equations with us. Can you get two equations in this situation? We will put the values of the roots one by one and get the equations. Considering x equal to 2 upon 3, we get a into 2 upon 3 whole square plus 7 into 2 upon 3 plus b is equal to 0. This becomes a into 4 upon 9, that is 4 upon 9a plus 14 upon 3 plus b equal to 0. Last time I told you a trick to simplify such equations which contain denominators. We will find out the LCM of the denominators and it comes out to be 9. So we will multiply each term of the equation by 9 and this will simplify the equation to 4a plus 42 plus 9b equal to 0, or 4a plus 9b is equal to minus 42. We need this equation, so let us name it as 1. Similarly, now we will put the value of the other root in the equation and we get a into minus 3 whole square plus 7 into minus 3 plus b equal to 0. Simplifying further, we finally get the equation 9a plus b equal to 21, which we will name as equation number 2. What kind of equations are these? You guessed it right, it is linear equations in two variables. And all of you know we can solve linear equations by three methods: substitution, elimination, and cross multiplication. You can use any method you like. I am using elimination method. I want to make the coefficients of b equal, so I am multiplying the second equation by 9, and so it becomes 81a plus 9b equal to 189. Now I'll write the first equation under it. Since the b terms have same sign in both the equations, I will subtract. So 81a minus 4a is 77a and 189 plus 42 is 231. Therefore a is 231 upon 77, which on simplifying gives us 3. Next we have to put the value of a in any one of the equations. As second equation is simpler, I am using it. So 9 into 3 plus b is equal to 21, or b is equal to 21 minus 27 equal to minus 6. So we have got the values of a and b both. Next comes how to find the solution or roots of a given equation. There are many techniques to find solutions depending on the type of equations you are working with. Today we are going to apply a technique which you are already familiar with. It's called factorization. Can you recall how you factorized a 2-degree polynomial? There are two ways. One is using the algebraic identities. The identities that can be used here are a square plus b square plus 2ab, a square plus b square minus 2ab, a square minus b square, and x plus a into x plus b. You already know how to use them. The second way of factorizing is splitting the middle term. You are also familiar with this method. Do not worry if you have any doubts in your mind, as we will go through several examples together to provide you ample practice. Let's start with a simple example: 2x square plus x minus 6 equal to 0. Whenever you are using the splitting method, make sure that the equation is in standard form. That means the terms should be arranged in decreasing powers of the variable. So this one is already in standard form. We'll take the middle term, that is x here. Coefficient of this term is 1. So we have to find out two numbers, say p and q, so that p plus q is equal to 1. Another condition which p and q must satisfy is that p into q should be the product of first and last coefficient. That is 2 into minus 6, which is equal to minus 12. The minus sign of the product indicates that the two numbers which we have to find will have opposite signs, and so their difference should be equal to 1. We can express 12 as a product of 1 and 12, or 6 and 2, or 4 and 3. Out of these, the one which has difference 1 is 4 and 3. So the values of p and q are plus 4 and minus 3. So x will be replaced by plus 4x and minus 3x in the equation. Next we will find the common factors of the first two terms, which comes out to be 2x here. Taking 2x common, we get x plus 2 in the bracket. Similarly, from the last two factors, we get minus 3 common and the two brackets should come equal. In the next step, we will take this bracket common and we are left with 2x minus 3 inside the other bracket. Now this expression is a product of two factors and product can be 0 only if at least one of them is 0. This means either x plus 2 is 0 or 2x minus 3 is equal to 0. Simplifying them, we get two values of x and these are the roots of this given equation. Let's try another example. Here the middle term is 7x and the other two terms contain roots. So we have to find p and q such that p plus q is 7 and p into q is root 2 into 5 root 2, which is equal to 2 into 5, that is 10. Clearly 2 and 5 are the factors which will give us product 10 and sum 7. So 7x will be split into 5x plus 2x. Taking x common from the first two terms, we get root 2x plus 5 in the bracket. From the second part, root 2 is the common factor and again we are left with root 2x plus 5 in the bracket. Taking root 2x plus 5 common in the next step, we get another bracket x plus root 2. As the product is equal to 0, this implies root 2x plus 5 equal to 0 or x plus root 2 equal to 0. Simplifying them, the values of x are minus 5 by root 2 and minus root 2. These are the roots of this equation. So these were two examples of splitting the middle term. Now let's try this one. Can you use any identity in this question? You may observe that two of the terms are perfect squares, that is 16x square and 1. So I can write this expression as 4x whole square plus 1 square minus 2 into 4x into 1. This way we can use the identity a square plus b square minus 2ab equal to a minus b whole square. Getting a perfect square means we have two equal roots of this equation. Simplifying 4x minus 1 equal to 0, I get x equal to 1 upon 4. So both the roots of this equation are 1 upon 4. And this is how we find the roots using an identity. Now can you try this one? Pause your screen and try it. And don't worry if you have any problem, as I will reveal the answer later. So you can cross-check and ask me if you have any doubts. Sometimes we come across such equations which are not of the form ax square plus bx plus c equal to 0, but they can be solved by reducing them to this form. Like this one. Here you can see that the variable is in the denominator. So I'll give you a simple trick to simplify this equation. Just find out the LCM of all the denominators and multiply the whole equation. That means each term of the equation by that LCM. LCM of x square and x is x square. So multiplying throughout with x square, we get 2 minus 5x plus 2x square equal to 0. And we have got the general form. Now we can easily solve it by splitting the middle term. The sum should be minus 5 and product should be 2 into 2, that is 4. Positive product indicates that the two factors should have same signs, but the sum is negative. It means both of them will be negative. So the two factors will be minus 4 and minus 1. Splitting the middle term into minus 4x minus x and simplifying, we finally get x minus 2 into 2x minus 1 is equal to 0, which implies that x minus 2 is 0 or 2x minus 1 is 0. Simplifying them, we get the roots are 2 and 1 by 2. Let's try another question of this type. This one contains a fraction on both the sides, so we can easily simplify this equation by cross multiplication method, which gives us x plus 3 into 2x minus 3 is equal to 3x minus 7 into x plus 2. Opening the brackets, we get this. Now bring all the terms from right hand side to left hand side and add the like terms. So 2x square minus 3x square gives minus x square, 3x plus x gives plus 4x, and minus 9 plus 14 gives us 5. The square term here is negative, and to make it positive we can simply multiply throughout the whole equation by minus 1. And we get x square minus 4x minus 5 is equal to 0. The middle term can be split into the factors minus 5x and plus x common from the first two terms and 1 common from the last two terms, and we are left with same bracket x minus 5. Taking x minus 5 common in the next step, we have x plus 1 in the second bracket. Putting each of them equal to 0 and simplifying, we get roots 5 and minus 1. Let's try another question where we have to reduce the equation into standard form. Can we use cross multiplication here? The answer is no, because both sides are not single fractions. So what to do? Well, we have to use LCM method here. LCM of x minus 4 and x minus 3 will be their product. So we have 2x into x minus 3 plus 2x minus 5 into x minus 4 in the numerator. Simplifying both numerator and denominator, we are left with single fraction on both the sides. So now we can cross multiply, and so we have 3 into 4x square minus 19x plus 20 is equal to 25 into x square minus 7x plus 12. We can write any side of the equation first. So I am first writing the right hand side now. 25x square minus 175x plus 300 is equal to 12x square minus 57x plus 60. Bring the terms from other side to this side, add the like terms, and we get 13x square minus 118x plus 240 equal to 0. Now we have to find p and q such that p plus q is minus 118 and p into q is 13 into 240. Let's find out various pairs of factors for this product and observe it carefully. So we find that minus 78 and minus 40 satisfy our conditions. So splitting minus 118x into minus 78x minus 40x and taking common, we have 13x into x minus 6 minus 40 into x minus 6 equal to 0. Taking x minus 6 common, we get the second bracket 13x minus 40. Equating them equal to 0 and simplifying, we get two roots are 6 and 40 upon 13. So these were some examples where we converted the given equations into standard form to simplify it. But there are certain equations which cannot be solved by this method. We need to do some substitution to simplify them. Look at this equation carefully. In one term we have x minus 1 upon x plus 3. In other term we have the reciprocal of this. So I can simplify this equation by putting x minus 1 upon x plus 3 equal to y. This equation becomes 2y minus 7 upon y equal to 5. Now as it contains y in the denominator, to remove it we will multiply throughout by y. And we have 2y square minus 7 equal to 5y, which gives us 2y square minus 5y minus 7 equal to 0. Now as it has been reduced to standard form, we can use splitting the middle term to simplify it. Minus 5y will be replaced by minus 7y plus 2y. Taking common, we get y into 2y minus 7 plus 1 into 2y minus 7 equal to 0, or 2y minus 7 into y plus 1 is equal to 0. Putting each of them equal to 0 and simplifying, we get the roots 7 upon 2 and minus 1. But these are not the roots of the given equation. These are the values of y which satisfy the equation number 2. To find x, we have to further solve this. So we'll put the value of y equal to x minus 1 upon x plus 3 and simplify to get x. We have two values of y, so we'll get two values of x from there. Let's divide the page and solve them side by side. Y equal to 7 upon 2 gives x minus 1 upon x plus 3 equal to 7 upon 2. Cross multiplying, 2x minus 2 is equal to 7x plus 21, or 2x minus 7x is equal to 21 plus 2, which gives us x equal to minus 23 upon 5. Similarly, y equal to minus 1 gives us x minus 1 equal to minus x minus 3, or 2x equal to minus 2, or x equal to minus 1. So x equal to minus 23 upon 5 and x equal to minus 1 are the roots of the given equation. It was a little tricky question, but if you practice such questions, it will become quite easy for you. So let's try another one. Can we solve this one with the same technique? Of course. We will put this root x upon 1 minus x equal to y, and this will become 1 upon y. So the equation will reduce to y plus 1 upon y is equal to 13 upon 6. LCM of the various denominators is 6y. So multiply throughout by 6y and we get 6y square plus 6 is equal to 13y, or 6y square minus 13y plus 6 is equal to 0. So we observe that minus 13y will split into minus 9y minus 4y. 3y comes common from the first two terms and minus 2 from the last two terms. So we finally get 2y minus 3 into 3y minus 2 equal to 0. Putting each of them equal to 0 and simplifying, we get y equal to 3 upon 2 or 2 upon 3. To find x, we will replace y by square root x upon 1 minus x. To remove the square root, let's square both the sides. So we get x upon 1 minus x is equal to 9 upon 4. Cross multiplying, 4x is equal to 9 minus 9x, or 4x plus 9x is equal to 9, or x is equal to 9 upon 13. Solving the other part in the same way, we get x equal to 4 upon 13. So the two roots of the given equation are 9 upon 13 and 4 upon 13. So I have covered variety of questions in this lesson and I hope you found this video helpful. We will cover another technique of solving quadratic equations in the next session. If you have any questions or comments, please let me know in the comment section. And don't forget to subscribe for more great video lessons.